learners. Welcome to Tyrant. Today we will be learning about sum of squares. We will be providing the numbers, we will be providing the numbers, and then we will be squaring them and then adding them to make the sum. Yeah. Now here given a list of integers, here is a given a list of integers and we have to find the sum using the squares of those numbers. Now here first we will import java.util.arrays and java.util.list. Yeah, these two important statements bring in utility classes from java.util package. The arrays, it contains utility method for arrays like as list, and the list is an interface representing a list, that is a collection of elements in a sequence. Yeah. Now coming further, we have the public class stream exercise 4 and the public static void main string args. This defines the class name. Here it defines the class name of the class, and the main method line, which is the entry point of the program, and the main method line, which is the entry point of the program. Now following further, we have the list whose generic type is integer, and the name of the list is nums, and following that equals arrays dot as list 234. Here it creates a fixed size. It creates a fixed size nums, that is the name of the list nums, containing three integers 2, 3, and 4. Array as list here. Array as list. It converts the given array into a list, and a list with generic type integer is a generic list that holds integers value. This will hold only integers value, as we have provided only integers value. And these functions int sum of squares equals nums.stream, then following that dot map n equals n square n into n, and dot reduce 0 comma integer sum. This is the core part of Java having API, stream API. Now let's break it down. As we come on to the dot stream, first we have the dot stream here. Dot stream, it converts the list into a stream for processing elements in a functional style. It will convert the list. It will convert the list into a stream. It will convert this list into a stream for processing the functional style. And now dot map is, yeah, it applies transformation to each stream, each element provided here, and for each number n. For suppose there is a number. Let's take this number as n only. N replaces with n with n square. If it will replace n with n into n, that is n square, n into n. And the original is consist of 2, 3, and 4, and the final onto the map list will contains the element as 4, 9, and 16. 4, 9, and 16. Here the original list is 2, 3, and 4, but here in the map list it will be containing 4, 9, and 16, as the squares will be provided for each and every elements in the stream. Now coming to dot reduce. Yeah. This is a reduction operation. This is actually a reduction operation. It compiles all elements of the stream into a single result. And 0 here. Here we can see that there is 0. Yeah. This 0 is an identity value. It is an identity value, starting value of the sum, and integers to sum. Yeah. This line is a method reference to integers dot sum in parenthesis a comma b, which results as a plus b. Integers to sum a comma b, that which results as a plus b. So it calculates 0 plus 4 plus 9 plus 16. Yeah. So it will be calculating all the values, sum of all the values starting with 0 only. First element will be taken as 0. Now coming further, we have the system.out.println line. This line will print the messages. This line will print the message, and the result of sum of squares. Sum of squares will be stored here. Sum of squares, and the sum of squares will be further printed here. And this is the message as they are within the double quotes. Yeah. And after that, there is concatenation done with the plus sign here, and with the sum of squares. Yeah. So coming here, we finally found that there is a list of 2, 3, 4 which we provided in the initial beginning. Then we have the map. Then we have the map having the squares containing the squares list. After squaring, the list will be contained in the map list only. And then we are having the sum. Then we are having the sum. With this reduce function, with the help of reduce function, we are having the sum of all those values. And finally, we are getting the value. So what is a stream? So coming here, we can say that this is stream. In the beginning, we have the stream. So what is a stream? Here, we can say that nums.stream. As we can see that there is a nums.stream. So we can say that stream is a pipeline of operations or collection of elements. It's a pipeline of operations or collection of elements or data. They don't store the data. The key point here is that they don't store the data. They process data from the collection. They will process the data. Whatever the data that is given in the list. They will process all those data that is given in the list. And coming here, they will process the data from the list, and from list to set. They will process data from collections, that is like list to set. They will process data from the collections, that is from list to set. And they support lazy. They support lazy, functional style, and declarative process. As we can see that n square, as we have the data in the list can be n, and finally they are processed into n square, n into n. Now in the map functions, we can see that all those things were mapped into functions. Now here in the mapping function, dot map is an intermediate. It is an intermediate operation. It is an intermediate operation at which lies between the stream and the reduce. It is an intermediate operation, and it takes elements from the stream. It will take the element from the stream. It will take the element from the stream and do the respective processes on that, and applies a function. That is in the case here. It will take the data from the stream and will apply squaring on them. This method is squaring on them, and it returns a stream of the results and results a stream of the result. As when the squaring is done, it will result the stream, and that is lambda expression. This is the lambda expression. This is the lambda expression, which is a shorthand of writing function, which we can say that is shorthand, which we can say that it is a shorthand way of writing the functions for squaring at all. And finally, we have the reduce, which will be collecting all the values and adding them, adding the reduce, and which will be reducing all the values, and for here it will be summing all the values, and the values it will return as single value only. Yeah. Now here we can see that all the values as will be done here, and here coming on to this reduce 0 and integer 0 integer is to sum. This is also a terminal operation. This is also a terminal operation. Here it combines all the elements into a stream with a single value result. You will combine all the values and will produce the result as single value only. And is an identity. It says identity is to string value. Here we have first value as 0, another is a integer dot sum. Yeah. And accumulator, it has two value functions. That first is identity. Starting value here is 0, as we have seen that first is identity as 0. Here has two functions. First is identity, another is accumulator. Accumulator, that will be accumulating all the sum. A function combines a function that will combine the integers to sum. A function that will combine the integers to sum. First is identity, other is accumulator. Now coming further, we can see that the first value is 0. First value will be taken as 0 only. I was squaring the value as 0, and second value will be 4, third value will be 6, and fourth value will be 14, 16, 16. And similarly, the sum of all those things will be summation of all each and every value will be done, and the answer will be 29. So what is integer dot sum? So we can see that what is integer dot sum. Integer is to sum. This is a method reference to a static method sum. This is I repeat, this is a method reference to a static method sum int a and int b in the integer class. It is a method reference to a static value sum a and b in the integer class, equivalent to a and b, integer a and b, which will be summed as a plus b, Now coming on to the different loops like traditional loop and this functional loop, we can see that this functional loop is much more better. As like we have the streams, then we have the map and reduce, then we have the reduce. Or we have the streams which will be converting all the values, data is provided in a list, and then we have the map for the functional part, and we have the reduce that will be accumulating all the values to a single part. So this will so this also less so this also helps in reduction of boilerplate code. So finally we found that finally by these functions or functional loops, we saw the benefits of the streams, that it has less boilerplate code. We were able to see all the things were done very much easily with the less boilerplate code, and easier to read once you are familiar with the syntax. It is easier to read the code when you are familiar with the syntax, and now encourages functional thinking. It will help us in encouraging the functional thinking, and can be parallelized easily using parallel dot stream. If you use that parallel dot stream, this this function can be used to further part also, to make other part also compiling here. Now for the functional programming concept, we have the immutability. We have seen that there is immutability. No variable changes during the stream processing. There is no immutability, which is said that there is no variable change during the stream processing. And for the pure function, like the n square, there is no side effect. There is no side effect, as everything will be done according to the functions of pure functions only. No changes will be taking place. No changes will be done here. And higher, it has higher order functions also, that state that functions passing functions like integers to sum as an argument. You have the integers to sum, integer is to sum here. Yeah. Here passing functions into integer to sum as an argument. Here you will passing all the integer, and that will be providing the sum of all those integers, squaring them, or whatever the sum will be coming here, that will be some summation of all the values will be done here. For finally, for this value, we have seen that from this program we have seen that we are using array as list to create a list. We are using array as list to create the list. Array as list to create the list. Then converting them into a stream with dot stream. Then converting them into a stream with dot stream, and then using the map, we are providing a functionality to them, all the data in the streams, and using their dot reduce. Using dot reduce, we are combining the data. We are combining all the data that is provided by the functional values, and then we are combining all the data here by the reduce. Yeah, combining all the data and using lambda expression to a method references, and use the lambda expression to the method reference. You are using lambda reference to a method references. So we can see that how the program is supporting the functional programming, and how is it improving the code readability and expressiveness. Now we are to the end of the program. We'll meet in the next class. Thanks.